Okay, so let's have a look. This is a typical example where we're trying to find the number of trials we need to have. So when Andrew is batting, the probability he hits a 4 on any one delivery is 0.05. Okay, so what is the least number of balls he must face to ensure the probability he hits at least 1 4 is more than 0.8? Okay, so we're looking for the number of trials or the number of balls that Andrew faces, so the probability of him hitting at least 1 4 is more than 0.08. So we've got the probability is 0.05. I need the probability that x is greater than or equal to 1 to be greater than 0.8. Okay, now given n is a number of trials, okay, I don't know if it's going to be from 1 to 10 or 1 to 20 or 1 to 30. Okay, we don't know how many trials. We could guess and check until we get a value immediately above 0.8. I guess a more exact way is, well, to consider that the probability x is greater than or equal to 1 is 1 minus the probability that x is equal to none. Because if Andrew has to hit at least 1 4, it's 1 minus the probability he hits no 4s. Okay, so if we rearrange that, what we're really looking for is that the probability that x is equal to 0 is less than 0.2. So the probability that Andrew hits no 4s is less than 0.2, because then the probability he hits at least 1 will be above 0.8. So if we work out the probability that x is equal to 0, that's n trials, 0 successes, 0.05 to the 0, 1 minus 0.05 or 0.95 to the power of n. All right, so if that all simplifies, just to leave me with 0.95 to the n is less than or equal to 0.2. And if I solve that on my CAS, I will get 31.377. All right, which means Andrew has to make sure he faces 32 balls. He can't face n is a whole number of trials. So it's either 31 or 30. And if he faces 31 deliveries, the probability won't be quite over 0.8. He's got to make sure he faces that 32nd ball to get the probability above 0.8. All right. So I guess what we're saying here is, if we consider the inverse binomial n function, it's always about the probability between 0 and the value that you're looking for. So whilst I need x greater than 0.8, I need to consider the area from 0 to 0.2. So we want the number of trials to be big enough so that the area, or the probability, is 0.2, and the probability of success is 0.5, and 0 successes. So what's that telling me? It's trying to find us the number of trials that I need to have so that the probability of 0 successes with a probability outcome of 0.05 is equal to 0.2. And that tells me 32 trials. Okay, so if I have 32 trials, the probability of getting no successes, if the probability of success is 0.05, is equal to 0.2. Okay.